Today let's try to solve another Leetcode problem 159. Longest substring with at most 2 distinct characters. So for this problem, we just need to return the length of the longest substring. That contains at most 2 distinct characters. So for this example, this E and C, there are 2 distinct characters, so that is okay. But for this ECE, it is still okay because there are 2 distinct characters, E and C, so the length will be 3. But while it goes to B, so there are 3 distinct characters, so it is not okay. So then we're gonna check CE, CEB. So for other case, the length is 2, but the maximum is ECE, it is 3. So this is basically the brute force to solve the problem. But for such problem, we can use a trick. For the inside the algorithm techniques, it will be called sliding windows. We just need to use a left pointer and a right pointer and check everything inside the sliding window. If the window is broken, then we need to fix the window. But everything, if it is inside the window, we just need to check the L pointer and the I pointer. So the distance between them will be the final result. And how can we check the unique characters? We must find some data structure for solving the problems. So the easiest way may be a hash table. And because we can use a hash table to count how many unique characters inside. And we can also deal with the hash table easily because we can delete the element inside the hash table and we can put element inside the hash table, and we can also delete the element. We can pop the element out of the hash table, so it will be easier for solving the problems. Now let's try to use a hash table and a sliding window to solve the problem. So I'm gonna use D as a dictionary in Python. It's a hash table, and then I'm gonna prepare result and the left pointer. So the D will be a default dict. So inside it will be integer. So this is just for the easy calculation of the hash table, and the result will be 0, and the left pointer will also be 0. Now I'm going to enumerate the R pointer. So for RC in enumerate S, I want to put the characters inside the hash table, and I also need to count how many these characters say. Because while I am deleting the character, I also need to check the count. So if the count is 0, I'm going to delete this K out of my dictionary. Now I'm going to check the conditions for breaking the window. So when the window will be broken, so I'm going to check the length of the hash table. If this length is more than 2, it means I've already found more than 2 distinct characters I have to handle with the sliding window. So before my the final result, the L pointer would be +1. But before that, I need to check the hash table. So for my hash table, I need to check this. So if this character is more than 2, it means I've already found more than 2 distinct characters. So let me just handle this hash table. So for this, it should be SL for this character, and for this counter, it should be -1. After -1, I need to check this character. If this character, for example, if this character is E, while I goes to here, for example, this is ECEB, So for this E, if I delete it, it is still okay. The sliding window is 3. It is still not okay. It is 3, but I have to delete another character, maybe delete this C, and then inside the sliding window it will be EB, and now it meets the condition. So first of all, I need to delete this character at the left side of my sliding window. Now I have to check this character, so it will be DSL. So if this character is 0, so it means this counter for this character, for this count becomes 0. So it means for my sliding window, I need to delete this character. Otherwise, my sliding window will still be more than 2. So how should I do that? I just need to delete some element, yeah, inside the dictionary. So I just need to use d.pop. So from the dictionary, I want to pop this character. After I pop it, so I'm definitely sure there will be no this character because the counter is to 0. The counter for this character equal to 0. And if it equal to 0, I need to delete it. If I delete it, so the window will keep to 2, not more than 2. Yeah. If it is a 2, it means the window is okay. I need to record my result. So the result would be maximum with the result and r minus l plus 1. Finally, I just need to return this result. Now let me submit it to check if it works. Yeah, as you can see, it works and it's pretty fast. Now let's check the result of the S. So the S is 10 to the power of 5, and the time complexity is ON because this is a sliding window problem, and the R pointer will always be shifted to the right, and this L pointer will also shifted to right. It will never go back, and this is actually ON time complexity. And now we're gonna use the same code to solve another problems. So it is the next problem. So the longest substring with at least k distinct characters. So there's just one change for this k value. Yeah. Now let me just copy the code from here to solve this problem. So we just need to change this 2 to k. Yeah, because basically the principle is exactly the same. We just need to check if there are more than k distinct characters. We have to fix the sliding window. After fixing the sliding window, we can get the result. So we just need to return the result. Now let me just submit it to check if it works. Yeah, as we can see, it works and it's pretty fast. And the time complexity is also ON, and the space complexity is ON because we used actual memory of the hash table. Thank you for watching.